Good afternoon, ladies and gentlemen. Dr. John Belkowitz, Intelligent Concrete, here to answer all your questions. We've got a Q&A Wednesday. I don't do that as well as Haley. Not as well as Haley. There you go. So we've got some awesome questions, getting into them today. I got a question, ding, from Muzamil Khan. Great name, sir. Hey, John, how are you? Doing well, thank you very much. Next question. Just kidding. How are you? Can you make a video related to economical concrete, like adding GGBS, which is slag, bagasse, I don't know what that is, rice husk, and I'm guessing that's rice husk ash, or some other chemicals without affecting its strength? You know, I'm very eager to do this from the past, but not having a lab like you. So you don't necessarily need a lab like ours. I'm going to answer these from last question to first question. You don't necessarily need a lab like ours to do some of these tests. I mean, shoot, if you can get a KitchenAid mixer, find something to use as a compressive strength machine, a closed loop hydraulic press, and you can even hire local labs to break things for you if you at the very least can make up the samples using 4x8 cylinders. Sorry. Going to the next question, I'm reading backwards right now. Can you make a video related to economical concrete, the SCMs, ASCMs, and other chemicals without affecting strength? And I'm guessing it's strength and durability. And I'm also guessing if we're doing an economical concrete, we're trying to reduce the most expensive portion of our concrete, which is our cement. And depending where you are in the US, cement prices go from 120 pounds per ton all the way up to maybe just shy of $180 to $200 a ton. Going overseas, I mean, proportionally, it's going to be the same, but overall cost might be less. That being said, anywhere we go, we always want to reduce the total cementitious content because it is going to cost us a lot of money. Now, it's not that we just want to reduce it by percentage, like adding 20% or doing a 20% replacement of Portland cement with, let's say, a Class F fly ash, or doing a 60% replacement with the slag. We also want to reduce the total binder component, and that's through something called optimization. So going this economical approach, let's say we're using a mix like we did in our last, or in our first PMXDB, which was an exterior slab on grade, 6 inches thick. I believe it was like somewhere between 4,000 and 5,000 PSI air entrained concrete. And in total, I believe we had 564 pounds total cementitious. Now, using this approach, what we would do is try to keep the fresh properties, the hardened properties, you know, the gray concrete coming down the chute, as well as those properties that the engineer needs to look at, as well as those properties that the owner cares about for that long-term durability. We're going to play with the aggregate to paste ratio by optimizing our aggregate. If we're only using a 57-67 or a 3/4 inch or a 19 millimeter, we're also going to add like a 10 millimeter, a manufactured sand, as well as that concrete sand, and maybe something in between to reduce the porosity index of our granular skeleton, that combination of coarse and fine aggregate, so that our paste goes a little bit further. Because quite frankly, that paste of convenience, we use it to get that ball bearing effect, where we have that paste act as a lubricant to allow that aggregate to mush past each other. So when we try to finish it or consolidate and finish it, it's creamy and dreamy instead of bony and nasty. So by playing with your granular skeleton, by optimizing it to reduce the porosity index or the amount of pores in that overall granular skeleton, we should need less paste or that binder water chemical combination to create that workability effect. So yeah, you could just use your slag, your ashes, your mined materials as a total replacement or as a percent replacement of your Portland cement, which is a one-trick pony. Anybody can do that. But to go after true economical value, you want to play with that granular skeleton to optimize it. And then it doesn't matter what you're putting in there, whether it's just straight cement or straight paste made from cement and other things, or it's cement replaced with a certain amount of some other supplementary material. So hopefully that helps, hopefully answered your question. There's a lot of different directions that you can go, and what we might do is, we started doing these revisitations of PMXDBs, right, Haley? So we can do one of those. We also have that batch ticket class that I want to start offering, and that has an aggregate to paste ratio. So maybe we can go through an optimization thing like this over here. Yes? Awesome! So thanks for the question. Hopefully you learned some. Let us know if you got any concrete questions, concrete concerns. Don't forget to like and subscribe. Ding that bell for notifications. Go concrete!
Beat asphalt!